All right, so shifting from 30, 60, 90 triangles to 45, 45, 90 triangles. You actually we've used this triangle before. So should be familiar with it a little bit, but we're going to talk about the ratio of side lengths that we get with this type of a triangle. All right. A 45, 45, 90 triangle is also known as an isosceles right triangle. And we talked about how all isosceles right triangles are going to have these angle measures. Okay, and that's because if you have two congruent sides, you know that the angles that are across from those sides are also going to be congruent. And if it's a right triangle, then you know they're both going to be 45 degrees. Okay. So because of this relationship where we've got two congruent sides, it makes it pretty easy to figure out what the third side, our hypotenuse, is going to be in relationship to them, because these two are the same length no matter what. So A and B are the same length. So it enables us to find what C will be in relation to those two congruent sides. And what we can do is we can actually use the Pythagorean theorem to solve for that third side. Okay. If we know that these both are the same length, we can solve for the third side. Now they used X for the lengths, and they figured out that the hypotenuse was going to equal X radical 2. Like with the 30, 60, 90s, typically we use A. So if these two lengths are equal to A, then the third side, our hypotenuse, would be A radical 2. And we can verify that through the Pythagorean theorem, which is what we used over here on the left-hand side. Now the process is exactly like what we did yesterday. We can label our three sides as A radical 2, and depending on which side we're given a length to, we can then solve for A and plug it into the other two sides to get their lengths. So just like yesterday, I had you guys write down that A, 2A, A radical 3 triangle. This is the triangle I would write down for today. Okay, this is the one we're going to be using today. Monday, we're going to do a combination of the two. We're going to do like a quick review of both types of triangles so you can identify them. But today we're going to be focusing on the 45, 45, 91. All right. So here's practice problem 1. It says find the length of X. So we're trying to find this length. Now I'm going to go and I'm going to write down my A radical 2. Okay. I know that that's the ratio we're going to use. So I look and see where's my number that we're given. What's the length? It's this one. So I know A is going to equal 5. Well, then I take that value of A and I plug it into the other two side lengths. I know this equals 5, so, well, X equals 5. If we were looking for the hypotenuse, we could plug that 5 value in for A here and get 5 radical 2 for the hypotenuse length. But the question they were asking for in this case was what the other leg was. Okay. So again, pretty straightforward. If they're giving you one of the legs, it's not too bad because you're given your A value that you have to plug in. The harder one is when they give you the hypotenuse, because now you're going to be dividing by a radical again. And remember, when we divided by that radical, we had to rationalize it. This is just going through this is part of, we figured this out, but it says find the length of the hypotenuse. We figured out that was going to be 5 radical 2. All right. Let's look at another one. Here's one where we're given a hypotenuse length and we need to find the two legs. So the hypotenuse is equal to a radical 2. The two legs are going to be equal to a. So my equation is what I'm going to set up right here. A radical 2 equals 3. So I need to solve for a, so I'm going to divide both sides by radical 2. A equals 3 over radical 2. Now, we talked yesterday, we don't like it when the radical's in the denominator, so we have to rationalize it. So the way you rationalize a fraction with that in the denominator, you multiply top and bottom by the same radical that's in the denominator. When you do that, 3 times radical 2 goes on top, and radical 2 times radical 2 becomes just 2 on the bottom, because the radicals, they undo one another. That's kind of the shortcut. Again, shortcut is the radicals go away, and it's just what's underneath it. You're actually multiplying them together, and you're getting radical 4, and the square root of 4 is 2. So once we know what A is, we know what the two leg lengths are, because they equal A. So these are both going to equal 3 radical 2 over 2. 3 radical 2 over 2. Sorry, hard to read. All right, that's how we solve it if we're given a hypotenuse. I think this one's pretty straightforward too. You're just given a length of 1. We'll get radical 2 over 2 for that one. The one problem I did want to talk about, if you're doing a problem like this, and let's say that the length we're given for our hypotenuse, actually, let's go back up to that previous slide. Yeah, this one. Let's say instead of 1, we were given that this length was, let's say it was it had like a length of 6. Okay, so we know this is a radical 2, a and a. All right, so if I want to solve for a radical 2 equals 6, then I divide by radical 2. I get a equals 6 over radical 2. I multiply top and bottom by radical 2. I get a equals 6 radical 2 over 2. Now, if you ever get to, excuse me, this point, in our example, we had like 3 and 2. And if you had a fraction 3 over 2, that doesn't reduce. And it's already in simplest form. In this case, 6 over 2, that can reduce. In fact, you can divide 6 divided by 2. Okay? This is actually equivalent to 3 radical 2, because 6 divided by 2 is 3. And just like you can multiply a number times a number, you can also divide the number by the number to get your solution.
Pardon the interruption. We have reached the middle of the alphabet. For picture day, I need my thoughtful, kind M's. I need my vibrant, witty N's. Send your M's, send your N.
Wait,
so you don't divide the radical by 2, though, right?
Correct, you do not. Yeah, you can't, just like you can't multiply the 2 times a radical 2, you can't divide it either. So those are 6 separate. So you just need to worry about the number part here. 6 divided by 2, which would be 3. Okay? So something to keep in mind when you guys are looking at those problems and you are rationalizing. After you get the radical out of the denominator, just take a look at the fraction and see if it's a fraction that can be reduced. Sometimes it'll just be reduced like a fraction. Like it could be something like, I guess when it's 2, it's gonna be an even number. It's probably gonna be something you can divide by, but sometimes it may be a number that can just be a reduced fraction instead of actually doing the full division. Okay. All right. Time to practice. So I'm gonna go ahead and assign that to you guys. So you guys are good to go on that, and hopefully you finish it up before you leave today.